Streaming? Back on the stream. Sorry, I just messed something up. I had to fix things. Otherwise, bad things could have happened. You know, leaking stream keys and whatnot. So, okay, so we're working on this wait if stopped. You know, macro. Which is based off of, oops, here. Go. Why is it not copying correctly? That's really frustrating. We'll just have to do this. Status, turn, status, and let's see, x f equals 0, 0x7f. Okay. Oh. Zig build, it's not Zig build, CD. Now let's watch. There we go. If wait if stopped. No, we get, let's do a, let's see, standard.debug.print completed. What is it not like that I didn't put the empty object in there? Now if we do, let's see, Zig out bin test bin. There we go. Yeah. Okay. So we did get it complete. So now it's about printing out information that we were interested in. So maybe we do like a peak text. And I was following this. Let's see. How debuggers work. Part 2 is the one I was reading. It was actually really helpful. Actually, it was debuggers part 1. So I was following some of this example here. question is, what was it? Oh, you know what? We do need to wait the child like that. While so yeah, this is where we have our loop here. Say while okay, so then what it's doing here is saying, hey, we're gonna count let's do this. This will be fun. Our counter counter plus equals 1 and so I use ptrace standard dot posix dot ptrace. Request is gonna be ptrace dot get registers. Interesting. was looking in the right place. Oh. Here's the struct. So what he's doing here is that, and asking for a pointer here. Some data. So what we need is to give it a pointer. Okay. So what we want is a struct that looks a lot like the one here. We're just gonna copy this. It's gonna work, is it? Nope. Is const Long longs are going to be U. There we go. That's going to be a U64. U. Okay. U64. Inside long long. Just check long long and U64. I'm going to go with that because long is 32. Long should be 64. Structure used by GDB and excuse me. Sorry. Used by GDB. From sys/user.h. Oh, and this should be just to be sure here, this needs to be a extern struct. I do extern because it needs to be a specific struct. So we're gonna do var. They make it. Do they remake it every? Yeah. Okay. Var registers equals registers. And we're going to say user start reg equals undefined. And we do registers. Yeah, so we need to do a pointer cast, I think. So this is a built-in int, no, pointer to int. Pointer cast. Should be int from pointer. There we go. For its value to a usize. we go. Let's see what he does here. Do standard.debug dot print. We're going to say instruction pointer equals IP. I should say I counter. Counter equals that. And instruction. It's going to be I counter. What is he using? Regs and EIP and instruction. Interesting, because ptrace returns void. Hmm. I hope this works. I see. I was mixing things up. I was reading two different things here. So he's doing the get registers here, and then he's peeking at the text to get the instruction. Which the Zig library, the ptrace, actually doesn't give you the instruction. Okay. Or whatever. I don't know. So we're going to just skip that for right now. Do register.eip. RIP. Let's do that. Oh, we need to then tell it to move along. Or else it just keep doing that. So then we need to do take a step. And a peak trace. Let me say single step. Trace that single step. Child PID 0, 0. Can't you do else error? Pretty sure you should be able to do that. No, I've seen it. Yeah. Standard that fatal. Can't do that. Okay, so I think that is enough to get us. Go. There we go. Let's. There we go. So you can see we're going through all the instructions. Let's see, oh, there's an interesting empty line. 7,000 instructions, more than I can hold in my history, which is fine. Excuse me. That's cool. Okay. Get back is instruction number 6. Let's see this new tracer run, our simply coded snippet. Okay. Okay, I think that is a wrap on that part. We got some basic, we got down to where it will break. So let's add breakpoints. Logic. Excuse me. I think that's the next thing we want to do. The next thing we want to do is we're going to create lib for making, let's see, creation. Okay, so we're going to do some breakpoint creation now. Okay, so the way we want to do this breakpoint creation is as this part explains. They've got this assembly thing. Problem is that their assembly and weird. I think it's, I don't know the syntax. I've tried compiling it, doesn't work. I don't want to rewrite their assembly. So we're just going to keep using our test program. That'd be actually interesting. Read elf on this bin. That's the yeah, okay. Entry point address 1034670. It just looks about right for what the numbers we were getting with the other, with all the instruction steps. Set a breakpoint at some target address in the target trace process. Debugger does the following. It's got to, remember the data stored at the target address. Place the first byte at the target address with instruction 3 instruction, interrupt 3. Then when the debugger asks the OS to run the process with ptrace continue, as we saw in the previous article, the process will run and eventually hit on the 3. It stops. Then has to replace it. Roll the instruction pointer tracer back one step. Allow the user to interact. Yep, and then when it's ready, move on. The user wants to keep running, the debugger will take care of placing the breakpoint back since it was removed step 1 at the target address, unless the user asks to cancel the breakpoint. The debugger template presented in part 1, forking a child process and tracing it. In any case, there's a link, full source code example at the end of the article. Okay. So you get ptrace get registers. I've already got that. Look at the word at the address we're interested in. So this We have break address. Actually, const. And we're going to do we want it to be continue. See, I was actually going to look at where he got. Note that entry point address. So my question is, why does he have the trap at that point? Because it's not at the entry point, is it? At some other point. Yeah. 8096, let's see. Okay. Okay, yeah, he looked at the disassembly. Dump local, no, zig out bin test. call main and exit main. Your test bin, not main. 103. So yeah, it's maybe we set the instruction point here, somewhere like bank, because we know that that's an instruction. 1034 B61. Got the break address. Now we want to find the ptrace, ptext. So I think here we're going to have to take a detour, which is we might have to write our own ptrace wrapper here, because right now it does an error no on it, but doesn't actually get the value which ptrace is supposed to return. It's kind of a pain. Ptrace, yeah, returns a U32. Or a U size here. So maybe we just call the Linux ptrace here, because does this not return? It returns a cent. Why? No. This is what's kind of frustrating with the wrapper here. Okay. Let's just call so yeah, now I want to read through man. Put ptrace here. Whoops. That is my footrest. The ptrace system call provides a means by which one process, the tracer, may observe, control, execution, PID of being traced. If the ptrace option is not in effect, then all successful calls to exec VE or trace cause sig trap. Okay, trace me, peak data, peak text. Read a word at the address. Address. Turning the word as a result of the ptrace call. Linux does not have separate text and data spaces, so these two operations are currently equivalent. The data is ignored. Copy the word data to the address adder and ptrace using memory. For ptrace peak text and peak data, these two operations are currently equivalent. Okay. So yeah, we definitely would like to see what's going on here, because when we do error no, on this, that does, it says, hey, if we use libc, right now we're not, so we say signed, size equals, we're going to bitcast the return RC. For some systems, this will obtain the value directly from syscall return value. For others, it will use it through a local error no variable. Therefore, this function only returns a well-defined value after the system function call whose error no is intended to be observed. It equals if signed is greater than -46, signed is less than 0. And it does enum from int. It's the integer. Yeah. Okay. Music stopped. I gotta put my music back on for myself. Let's see. So we need a new ptrace call here. fn ptrace. Let's take request, the type. It's U32. U32. Need to take a PID. And deposits the system. Signal data. Yeah. Request, we got the PID, we got the address, we have data. But it does return a ptrace error. Say on success ptrace peak operation returns the requested data. The ptrace succomp get filter operation returns the number of instructions in the BPF program. Ptrace get syscallinfo operation returns the number of bytes available to be written by the kernel. Other operations return 0. On error, all operations return -1. And error no is set to indicate the error. Since the value returned by a successful ptrace peak operation may be -1, the caller must clear error no before the call and then check it afterwards. That is atrocious. Atrocious, I tell you. But it's good to know. it is about that time. I gotta close up for the day. But thank you for watching. This has been great, a lot of fun. I'll see you guys next time.